Mighty fine good day, everybody. My name is Cale Harbor with Advanced Control Solutions and Automation. Together with our partner companies within the Applied Automation Group, Olympus Controls, and Gibson Engineering, we're excited to have you join us for today's discussion, the empowering of the connected operation with edge-enabled vision systems. Our speaker today is Matt Moschner of Cognex. Matt is a senior director and leads the global engineering development and marketing of the ID products. Matt is also deeply involved with developments in the area of Industry 4.0, working to take the valuable information generated by Cognex devices and transform it from big data into smart data through edge intelligence. It's my pleasure to present to you today Mr. Matt Moschner.
Hi, everybody. It's great to be with you. I'm calling from our Natick, Massachusetts headquarters here at Cognex. And first of all, I want to thank our hosts. Very exciting to be here with you all. And as mentioned today, I'm discussing edge-enabled vision. And really, maybe a better name for this talk is edge-enhanced vision. You know, of course, at Cognex, for many years, we've been deploying smart vision systems at the edge, and believe and have seen the benefits of that. But really, this talk is how do we add additional processing at the edge to supplement what those vision systems can do, and what are the most common use cases that we're seeing even today when we do that. Before we dive into that topic, I thought it was worth briefly giving you our view at Cognex of how we see the current state of Industry 4.0. And I really think of it in three ways. The first is the systems that we're deploying are increasingly complex, and they're increasingly interconnected amongst very different devices. And I'll talk a little bit more about that, but that's important. The second is our customers, and I'm sure many of you are seeing this as well, are trying to do more without adding more. And that, of course, is the spirit of automation, but really is the promise as well, in many ways, of edge computing. I'll talk a little bit about that. And the third is, our customers are really looking for access anywhere, right? Not just on the factory floor or within the four walls of a distribution center, and not just during production. And of course, information security is only becoming more relevant. And so when I think of Industry 4.0, these are really the three largest trends that we're tracking towards. Let's try to unpack those a little bit. The first, complex interconnected systems. What does this mean? Well, it's certainly more sensors, it's more connections, it's more sources of data, but it's more sources of real-time data. And even perhaps more importantly, where that data is coming from are from different types of sensors, whether they be encoding systems tracking movement, whether they be distance sensors, whether they be full-fledged 3D systems, whether they be 2D vision for barcode, 2D vision for inspection, whether they be other sorts of laser-based dimensioning systems, weighing scales. Really what we're seeing is to solve some of our most complex customer issues, we're having to bring to bear a lot of different smart devices that themselves are already edge-based computers, but working in tandem with each other to do something more. So we'll talk a little bit more about that. The second is doing more without adding more, right? And this is really about taking your current operation and how do you get 5, 10, 15% more throughput without even, let's say, not increasing the speed of your conveyor, right? Shortening the gaps. How do you reduce waste, so you get a higher yield? And how can you react to issues, right? Issues do come up. How do you find them faster and solve them quicker so that you're back to peak production faster? And then last but not least, access anywhere, anytime securely, for sure, better visibility. And a lot of Industry 4.0, I'd say over the last 10 years has really more been focused on this problem, is how do we get data off the factory floor, securely to more stakeholders and make it more relevant data so that it's not a day old or a week old, but it's an hour old or 15 minutes old. And that trend is still very much alive and well. And then, of course, the stakeholders that want to be involved here, that need to be involved here, are only getting more comprehensive, right? It's no longer just our process engineers. It's the IT department that's executing on their digital transformation strategy. It's the executive team that want to be able to view production results hourly on their smartphones. It's all this, right? Which is really the promise of Industry 4.0. And what's fun is a lot of these things are now attainable with the technology that we see coming to market. I also, before we dive into the details, wanted to just address, the word edge and what role, how do we define it, and what role do we see it playing in Industry 4.0? And so we define, the quote unquote edge as moving computing processing as close as you can to where the raw data is being created, right? And so in the purest sense, actually our smart cameras, obviously are edge devices. They have their own processors. They are very powerful in their own right, and they are making decisions on images in a matter of milliseconds, as few as 15 to 20 milliseconds processing an image for the purpose of reading a barcode or making some sort of inspection. But even more so, if you move up that stack, right? This term, the fog, which is maybe not the device running on the line, but is additional processing consuming those data in a matter of seconds, right? And I'll talk a little bit about that, and that's really where I want to focus this talk, which is around how do you enhance the performance of a vision system with additional processing. And it's additional processing that's typically dealing with data streams from multiple sensors, right? Think about that first mega trend, increasing complexity, increasing sensors. Where we see a lot of the value is being able to place additional processing that absorbs those many data streams, is able to do more with it and say more from it. For sure, edge computing has its benefits, as does cloud-based on or off-prem cloud-based computing. But when you're on the edge, you're typically concerned with faster cycle times. You don't have the time it takes to take information, push it to a virtual cloud, have it being processed and sent back. Often, still on the factory floor, bandwidth is a premium, and we know that. And moving large streams of raw data, particularly image data, 2D or even 3D information, is still very expensive. And so being able to process it as close to where it's created is really valuable, and be able to either compress it, down select from it. And I'll talk about a couple examples. And then, the third is really about really just retaining the information that you need. Again, there's a lot of sensor data that is often being created on these more complex systems, really on really any piece of automation equipment today. And a lot of it is duplicative. A lot of it is not really that value added. And so a lot of what we see as the value of additional edge processing, particularly with vision systems, when there's a lot of really sort of memory intensive image data, is that filtering and only keeping the information that is most valuable, only retaining it, only post-processing it when it's valuable. And of course, as you move up, when you have minutes, hours, days, when you need to keep information for longer, moving it to an on or off premise cloud. Okay, so I think this is a helpful starting point for what we mean by the edge and what we mean by edge enhanced vision. There's really 4 use cases I want to talk about today that we most commonly see edge enhanced vision use cases, with the value you can bring with additional processing close to smart cameras on factory floors. The first is managing those many different devices. As I mentioned, the number of sensors is growing, of varying types, right? I'm not just talking about vision systems. And your ability to manage configurations, firmwares, permissions, network settings becomes more expensive, and the opportunity for error goes up. And so, pretty simple, but still very important, is how do you manage that? How do you get visibility in a single view of all the devices operating? And how do you interact with them really efficiently without needing to deploy teams of people to physically check on them? The second is more of a runtime benefit, which is how do you monitor the device, or more often the system performance in real time, and take action, right? It's one thing to view, kind of read the news, see how things are going, but it's another to see, what the likely cause is, and what the likely recommendation to fix it is. And so we see a big benefit of additional edge-based processing with vision systems there. The third is creating new data streams by combining or enhancing device results. So what does that mean? Well, like I mentioned, often when you pair a vision system with some other sensor, let's take an encoder, for example, you can track an object through the field of view of that camera. That's one example. And so that's a good example of marrying one sensor modality with another and being able to create new information. And then you can multiply that across more cameras. Another good example is image data that I'll take you through, where you can combine images, let's say, from multiple views or multiple cameras, and that's can result in a different type of inspection. And there's a lot of benefit there doing that on a separate processing unit, again operating at the edge. And then last but certainly not least is more easily making those data accessible to other cloud or Industry 4.0 services. So by now, we're well into this journey in Industry 4.0. A lot of our customer systems integrators and partners have been on this path and have been on this journey. Either they've invested in their own cloud infrastructure, they have their own server rooms on site, they have their own kind of digital strategy, and that's great. Frankly, as do we. And so, but there's often a challenge to how do you plug into that and how do you drive compatibility with it. And so it's really important, and where additional edge processing can really help is to format and structure that information coming from different sensors very, very quickly and push it into those systems predictably in a standard way. So as you add new sensors of different type, you don't need to keep reworking that data pipe up into your clouds. And so these are really the 4 examples I'll talk about for probably the next 10 minutes. So let's take the first one: manage users, permissions, device configurations all at once. So imagine this scenario. It's obviously a bit of a cartoonish scenario, but where you have multiple vision systems connected, and this is really about what role could additional processing. In this case, it's an industrial PC, but you could imagine this any piece of software running on a local processing unit. And here are very common, albeit very specific tasks that our customers often ask for, and ask for not just for 2, 3, 4 vision systems of the same type, but 100, several hundred, thousands within a facility that are 2D barcode readers, 2D vision systems, 3D sensors, quote unquote, dumb sensors, encoders, photo eyes, triggers, things like this. They want to be able to monitor all of those things from a single portal and be able to do things like on a group basis or a device by device basis, set user levels, modify networking settings, update software, right? Like we all know how painful that is sometimes. Manage configurations, monitor when those configurations change. At Cognex, we're always releasing new features, and so if you want to take benefit of those, upgrading the software feature keys on those units. If it's a vision system, managing the vision job. There's a whole host of things that you need to do to any sensor, and particularly vision system, over its life cycle, so that it's running at peak performance. And having to connect to each of those devices takes a lot of time and is very error prone. And so we see additional edge processing as adding a lot of value in being able to manage that device fleet from a single portal. Let's take the next example, which is monitor device and system performance in real time. I think in many ways this is like the one example that everyone thinks about when the term Industry 4.0. It's like predictive maintenance. It's like, how do I know when things fail before they fail? And that's a valuable aim, and I think we're not too far away from that. But again, let's take this simple example where you're connected to a fleet of vision systems, let's say several hundred today, often to monitor the performance of those systems. It's a lot of custom programming. We have customer-facing APIs that we publish that we let our customers develop against, and that's great. It does require some, quite a bit of expertise and time and money if you're outsourcing it, but you can create graphs like this where you're tracking throughput, read rates, inspection pass-fail results, quality of barcodes, throughput, device health, even device temperature. There's hundreds. I mean, I think a Cognex DataMan system has 150 public data points that you can read out from the device, and there's several hundred more that aren't public. And so there's a lot of information you can track. But getting it off of very different sensors very quickly is a challenge, and we see that additional edge processing as almost like a data buffer, and being able to synthesize that information in a viewable, digestible way is extremely valuable. And saying, why did throughput fall? Why did read rates fall? And being able to point to things, at least in barcode reading, often the most common is being able to physically look at the images and having those edge boxes being able to automatically collect events, anomalous events like no reads, and visually saying, oh, okay, well, something happened with my light. Clearly, I'm getting a whole lot of glare. That's not what I was intending. And then you can dig into those issues further. And so, part of this is collecting the information efficiently, displaying it in ways that are relevant for the application, but then also being able to dive into the root cause of those issues really easily. And we see edge processing is really a great way to do that, because a lot of the times you want this information to be relevant, again, in a matter of seconds or at most minutes, and edge processing is really necessary to do that. The third, I think, is maybe the most interesting, is how do you create new data streams by combining or enhancing device results? So here's, again, another high level, but I think interesting example. If you take, let's take a couple of vision systems, in this case, the DataMan 470 and 370. If you're triggering these devices, let's say in a continuous mode, you're going to get images that kind of look like this. A lot of duplicate information. And the reason for that is so that we always have a shot of the code, right? And we have math that figures out how quickly and how much overlap you need so that you're never at risk of missing the code. And we actually like to get multiple shots of those barcodes. And so you can see an example like this. But what happens when you just want the one image? I don't want all those images because then I have to sort through them. I just really want one image of that box. Well, the additional edge processing unit can really help you with that. The first is to eliminate duplicates, right? You can imagine taking out image data where you have duplication, and then actually being able to merge it either through tiling or more sophisticated stitching and image processing, so that what you're doing in the end is just result of a single image, and that single image is a merger of multiple images, and that's the data that you're saving either locally or in the cloud. There's other examples like this where you can take the raw data off the cameras that we're doing one thing, and let's say run a deep learning training algorithm on those images, and your enhanced result is a trained network that you can then redeploy to the cameras. There's a lot you can do when you couple this sort of edge-based processing with the smart cameras themselves. And then the last example is easily make data accessible for other cloud services. And so again, here we have our graphic, and you're collecting results from end devices of different types. But instead of viewing it and collecting it locally, we want to take those results, and those results could be the raw results. They could be somehow an enhanced version, like I mentioned in the last example, of those results. But we want to we want to share them to a cloud service, to a virtual cloud, an on-prem cloud, and it doesn't matter which one, but using a common protocol to do that. And either there's multiple reasons for it. It's either collecting information across multiple sites. We've got sites in the West Coast, the East Coast, in Europe, and Asia. Longer term data retention, where storage is a bit cheaper than in the factory, or merging with other IoT data sets. And that's highly varied. If you have other mechanicals, robots, fluid pumps, mechanical conveyance, temperature, all sorts of other information that you want to merge together with the machine vision data. And then, of course, being able to view that virtually, offsite, anywhere, and of course, securely. And so, again, in this case, the edge processing can supplement the vision system, again, acting as a buffer, but then as almost like a data formatter and a data forwarder to the cloud. And doing that only with the right data, maybe at the right time. You can time uploads to make sure that you're keeping up with the bandwidth allotment of the site. All right. We've been working on this for a couple of years now. We launched a product, Edge Intelligence. I won't really talk too much about this product, but it really is in the spirit of what I just discussed, and really is meant to serve a lot of the core needs that we discussed around being able to manage fleets of devices without custom programming, and collect their data, identify performance issues sooner and faster, create new data streams by combining and enhancing results, whether that's performing additional vision on those images, merging that data with other sensor types, and then finally being able to use, buffer that data and forward it to other cloud or Industry 4.0 services. And so we're excited about this new platform, and it's something that you'll see a lot more from in the near future. Okay. Great. I think that's all I had. Hopefully I hit my time slot, and I'd be happy to answer any questions.
Thank you, Matt. Yes, time slot is perfect. I've been watching the chat room. Only a couple things have come in. So, Matt, in regards to Industry 4.0 and the edge intelligence, are there certain communication standards that are coming out to be dominant within that world right now?
Yeah, the one we really like is MQTT, and that's a publish subscribe method. And the reason we like that, I mean, first of all, we see a lot of our customers adopting that standard. We see a lot of the cloud vendors adopting that standard. And so that's the one that we've driven first in terms of integrating into our initial version of that product. Of course, there's a lot of other ways to share data, whether it be FTPing images directly to specific destinations, or things like that. But I'd say the MQTT publish subscribe method is the one that we like a lot, and that we've launched with the product initially.
Okay. What steps are you taking in place to deal with internet security this day and age to get people, or to keep people from accessing the manufacturing floor for either hackers to get in, or just protecting the data itself as you're sending it out for analysis?
Yeah, no, it's a great point. I mean, information security is probably the first question we get when we have discussions like this. But I think there's a few things. First of all, I think information security, the best, is actually a case for edge processing, right? A lot of it is keeping that sensitive data close to where it's produced, and being very careful about what information you push off-site, because once it's off-site, it's inherently at greater risk. A lot of our customers look to Cognex for support on issues, let's say, or enhancements we're making, but a lot, and so we access that information remotely, but a lot of that is done through permission systems that exist on those edge devices. And so we need to be granted access before we can just sort of like tunnel into devices. The other very common way that we see customers dealing with that is actually redacting information sometimes, where you can blur images, you can have watermarks on them. There's a number of different ways that we do that. And then of course the vision systems themselves have quite a bit of security in them, so that you can't actually manipulate their operation and put that at risk. And so there's a couple levels of security actually.
Okay. Is there one dominant either application or industry that started adapting this Industry 4.0 interface with machine vision that you've seen so far?
Not necessarily. I'd say we're seeing it almost across the board. Um, you know, we play in both factory automation and logistics, and I'd say both markets are clamoring for this. I mean, if you think about the three trends, a lot of device diversity and sensor, just volume of data, as well as doing more with not adding more. I think both producers and distributors are grappling with those problems. Where we've been deploying maybe a lot of our most complex systems have been in the logistics market, in barcode reading at least, where we have in some cases 20, 30 vision systems that are working in tandem to solve a job, which is to read, find and decode the barcode, or multiple barcodes on all sides of a parcel. And so there, I think we've seen a lot of benefit being able to position an edge computing unit to absorb, filter, process so much data from so many cameras. But I think that problem is not necessarily unique to logistics, and we've seen it in factory automation as well. And so no, I wouldn't say that we're seeing it more or less. We're seeing it more everywhere.
Okay. Fair enough. Fair enough. Well, that was all the questions I saw that came in during our time today. Matt, I'd really like to thank you for spending the time to let us know what Cognex is doing within this realm. It's definitely the edge intelligence and Industry 4.0 is going to be a growing part of what we deal with in the automation industry and what we deal in our day-to-day lives. I'd like to thank the audience for attending today. This session is recorded. We will be placing it on our YouTube channel, so you feel free to log on in the next day or so. Be sure to like our channel, rewatch the video, or share it with someone else who might benefit from this. Likewise, the online show today is still going to be open for a while. Please go to the vendor booths and request a meeting. If you'd like to learn more, check out the Cognex booth, request a meeting, and we'll be sure to follow up with you, answer any questions or concerns you might have. Once again, Matt, thank you very much for being with us today. We've enjoyed having you.
Thanks so much. Thanks,
Take
everybody.
care.